Hello everyone watching this video, and we are discussing our chapter rotational dynamics, the rigid body dynamics. Hello everyone watching this video, and as you know that we are discussing our chapter rigid body dynamics, in which we have discussed the center of mass, the rotational motion and the moment of inertia, and our next topic, the torque, which we will discuss in this video. So here, before explaining the torque, I would like to explain the rotational motion again. So here, if we have an object and this object is moving on a line, and after some time it changes its position and it's reach here after time t. So this motion we call linear motion or 1D motion. So in the linear motion or in the 1D motion, object changes its position but it moves on a straight line. We can say this straight line motion also. In second case that we have discussed, suppose a object is take a flight and reach over here. So this object showing a motion in this direction and showing the motion in this direction also. So this object showing motion in two directions. So this is called 2D motion. 2D motion, and we gave it one more name, which is motion in plane, or we call it projectile. So there are three names for this type of motion, in which object show the motion in two directions. One is linear, other one is in the perpendicular to the horizontal or perpendicular to the first motion. So this motion we explain by two directions, so we call it 2D motion. This show the motion in complete plane, so we call it motion in a plane, and also the projectile motion. And first one was the simple motion in the object move along a straight line. So this is also called straight line motion, or one dimensional motion, or linear motion. There is third type of motion, in which an object moving on a circular path continuously, then this type of motion is called circular motion. So it's simple. If an object takes or moves along a circular path, then this type of motion is called circular motion. So there are three types of motion that we have discussed previously, but in this chapter we will discuss the rotational motion. Some people or some students think that rotational motion is simple or like as a circular motion, but it is not. Rotational motion is completely different from circular motion. In all three type of motion, there is a simple, there is a common thing. In first, second and third case, in all three cases, object is changing its position with surroundings. Here, this object changes its position from here to here. In this case, the object changes position from here to here, and in this position, this object moving along circular path and changes this position from here and somewhere else. So in all three cases, object is changing position with respect to time and surroundings also. But in the rotational motion, suppose that this is the body and this body is in the rotational motion, then this does not change its position, or we can say the center of mass of this body does not change its position with respect to time and surrounding, but body shows the motion, or particle of the body shows the motion or changes its position. So its center of mass remain at rest, but the different part of the body shows the motion. How it is possible? Suppose there is an axis and this our body is moving about this axis. Suppose that this is the body, or this is this pen, and here its center of mass, and this center of mass is fixed between my two fingers, and this is moving like in this manner. So all the particles here and here, they are moving or their position is changing continuously with respect to time and surroundings both, but center of mass remains stationary. So we cannot say this is linear motion, projectile motion or circular motion, because in all three type of motion center of mass is changing its position. But in the rotational motion, the center of mass remains stationary and other part of the body comes in the motion or shows the motion, or this body or this part is moving about an axis. So this type of motion is called rotational motion. In this case, the center of mass remains stationary and other part are moving. So here we will discuss or we will compare. First I write the name. We will compare first and fourth case here. So in first case, if this object changing its position from here to here, we say this is showing an displacement which we represent by small s, and if taking is showing some displacement with in time t, then we say that the displacement is changing. So we explain that by change in displacement we explain by the velocity, and if its velocity is changing with respect to time, then we show that by the acceleration. So there are three factors here in the rotational motion. If this particle here is here and after some time it reaches here, then we show this displacement by angle theta, which we call the angular displacement. So here the center of mass remains stationary, but other body part are changing the position, and that position we explain by the angular displacement theta. And if this displacement is changing with respect to time, then here comes the angular velocity that which explain the change in displacement. And if omega is changing continuously with respect to time, then we explain it by the angular acceleration alpha. So in the linear motion we have displacement, velocity and acceleration. Here also we have the displacement, velocity and acceleration. All three things are here. And now we are coming at our topic, the torque. In the linear motion we have one term that we call the force. The force, you know that each and every body which have mass, which have the inertia, and inertia is the property which resists the change in the linear motion. And here in the rotational motion we have the moment of inertia, which is same as inertia and which also resists the change in the rotational motion. So here we have a quantity force, which is the property or tendency to change in the motion, or we can say change in the linear motion. So force is a factor. Force is something which changes in the linear motion of any object. And here in rotation motion we have the torque, which shows the same property that shows the force in the linear motion. So torque is something which have the tendency to change in the rotational motion. So torque is something in the rotational motion like force in the linear motion. So here we write the definition of torque. We write the definition of torque, which is the torque is defined as the tendency to change in rotational motion. Or tendency of force of rotation. So this is the definition of torque. So torque is something, or torque is defined as the tendency or property of the body to change in the rotational motion. So this is the factor, you can say property, factor, anything which changes in the rotational motion of the body. So this is the definition of torque. So now we will discuss after it that how we write down the formula or value of the torque. Please write this definition in your notebook, and now we move forward. Suppose that